Welcome to Cat the Minion Energy Work. My name is Teresa, but you can call me Cat. This is going to be an energy report, and it's easier for me to not be on camera right now, just in terms of available spoons and functionality, RE, autism. So I've had a download recently that has to do with numbers and geometry, and I've been sitting with it for a few days because I wasn't super confident about the material or explaining it, and I had a lot of critical stuff going on in real life. So I'm just kind of, my notes are all scattered, but I've got some fresh sheets of paper and a Sharpie, so I'm going to get the camera down off of my mess pile here, and we're going to get into this. Where I want to start is the beginning of the download. Now this is like a zip file full of information that comes in, and it's like associate's degree of information in like a second. And sometimes when I get downloads, I'm like, all right, that's enough. Like, and I sort of stop it midstream. Because I'm usually in the middle of doing other stuff. So let's get into this. So what we're going to do is start where I started. So what I got, the information was about the number 1 squared. Now any number squared equals that number multiplied by itself. But with 1 times 1, it always equals 1. And if you did this infinitely, you would just be multiplying 1 times 1 times 1. My infinity wasn't aligned properly. Let's see if I can do this a little better. All right. So we have 1 to the infinite power is always going to equal 1. And if I wanted to represent this as some kind of unit, I could have a circle, or I could have a sphere. It's supposed to be shading. It's a little better. Looks like the AT&T symbol. Or I could have like a square, and this is my unit. Especially if I say 1 is a line, my unit, and 1 times 1 would be my square. So this is 1, and this is 1 squared. Now, if I were going to do this infinitely, I might take my square and say, okay, well, 1 cubed, so even though that's not exactly equal, now I have a cube where each side is 1. But what if I was going into the 4th dimension? I would be getting a hypercube. And the way that it's rendered usually looks kind of like this. Where it's kind of like a cube that's suspended within another cube, like it's swinging on ropes. And then we can see the other part behind it. So if we were to say that with a sphere, it ends up looking a little differently. And I did have to go and research this a little bit just so that I would understand what a hypersphere is like. Now, my initial understanding of a 1 squared, so we still start off with 1, and then when we change that into 3 dimensions, we start to look at it from a different angle, and it slowly, the line turns into a circle. And then to get it cubed, it becomes the sphere. If it's going to go into the fourth power to become a hypersphere, my personal expectation is that I would see a torus. And this is without really studying it or thinking about it, right? It's like a donut. Actually, I have a donut. Let me go get it. So my expectation of what a sphere into the fourth power is that it would look like a donut, where we can crawl up the inside and out the top, and then back around, and then up the inside again. So let me get my delicious donut out of the way. So we're going to pretend that this little doodle here is the same as that tasty looking apple cider donut. Okay. So maybe if I draw a toroidal form a little bit better. So it's going to come in. Kind of like this. Okay. Now, a torus is typically formed by a circle or a disc that's spun in a circle of its own. So if I spin this disc around an axis, I'm going to get a donut. And usually we see that when we take a little cross section of the toroidal form, and we see that the cross section is a disc, and I just keep adding discs to it, and it starts to look like a pumpkin, and then it starts to look like a whole torus again. And if we looked at the torus from the top, let me get the other marker again. If I look at, like when we saw the real donut from the top, it looks like this. And we can see that there's a hole that goes all the way through. And if we were only looking at the hole, a donut hole is really not going to be a munchkin like this, like you get from Dunkin' Donuts. The real donut hole is going to look like this. Which is something that we would normally call a wormhole. So this is the inside that you can see coming out. You know, and it's also like your butthole or your mouth hole or whatever. There's some organisms that are shaped just like this. I think like, was it like coral or something? It's been a long time since I was in college, but when I had vertebrate zoology, we go through like sponges and all those kinds of invertebrates and, you know, what was it called? The gastric something or other? I don't remember. So anyway, the point is, my expectation is that there would be a torus. But what actually happens is, much as if the flat person is looking at a disc that's turning, right? I start off with my 1, and then I can see it changing shape as it becomes the 1 squared, the disc, which is here. And in between, it looks like an ellipse, which is how I saw it explained on YouTube. And since a hypersphere is a hypercube is a bunch of cubes linked together, what happens is that the hypersphere, let's get this, it's almost a football, but it's like more like a potato. We end up looking at a sphere as if it was distorted. Much like this stage right here. Kind of like with the moon, but a little bit different. And what happens is that a whole bunch of these sphere-tatos, actually that should be more round. Let me get a a whole bunch of those sphere potatoes end up stacked up on top of each other. Creating a new sphere shape. Now, really, there wouldn't be any space out here. It would kind of stretch out to fill that, but that's kind of what the hypersphere is supposed to look like. And you have the ability to, much like the donut here, to walk on the outside and then end up on the inside without having to break through the surface area. Now, the hypersphere, to me, looked a lot like a planet, especially if you consider that time on a planet has to do with rotation. So if this is the North Pole and this is like North America and South America, just for funsies, right? We are looking at saying right here, it's 3 o'clock in the morning, and over here in California, it's only midnight. And time is caused by the spin. So even though we say that fourth dimension is time, it's kind of like a distortion of the space, or another aspect of the way that the space communicates with itself. It's the way the space like layers into itself. So in terms of thinking about a planet, for me, the hypersphere for the planet, the inside, would look like an infinite series of interlocking circles or spheres. And this would make the donut shape, except on the planet, they are so tightly pushed together that there's no hole. Kind of as if you were looking at a clementine or an orange or a grapefruit. So on the clementine planet, I'm just saying clementine because I've been eating them for a couple days. Right? I don't have the orange marker with me, so we're just going to use the red one. This is our clementine planet here, which is an oblate spheroid because of gravity. We see that all of these sort of sphere identities are overlapping. But if I wanted a torus, I would want those not to be overlapped. I'd want them to be a little bit apart. I'll get a different color marker. In my donut, my spheres are apart. My overlapping spheres are apart. Which creates my wormhole, my tunnel. One of the important things to note is in the fourth dimension, if I want to see my hypercube from all sides, if I want to see all sides of my cube, alright, so let's just say that each side of the cube is a different color. If I want to see all sides of this cube, then I need to walk around it so that I can see it from the other side. In the 3D. Or in this case, turning it that way too, since I'm drawing the entire other side of it. Hopefully that's not too confusing. If I want to see both sides of this, I have to either walk around it or I have to flip it over, or both, so I can see all of the sides of the cube in the 3D. But if I'm in the hypercube up here, at some level, without moving, I'm seeing all of the sides of the cube at once in a way that doesn't entirely make sense from the human perspective. But some of that is because the energy... That's 6. I feel like I'm missing a color purple. Some of that... So, in this hypercube space, I can see more sides of the cube. I'm getting all 6 of the colors instead of only 3, without really creating that spin. But when you do see an animation of a hypercube online, this is kind of a really bad version of it, it's going to be constantly flipping inside of itself, so that the pieces on the outside are going to swing back and then this part that's now in front of us is going to look like the bigger part, and the part that was the bigger part is now in the back, looking like the cube is moved again. So it goes from this mess to one view, and then it flips back. I know I'm a no-budget production, so I can't really animate that myself right now. Now, another part of this is that a hypercube, at least in Madeleine L'Engle's books, is thought to be the same as a tesseract. But the way that a tesseract is explained is the same way that you would see a wormhole. Or like a wrinkle in time where we're folding the fabric and the ant... I'm trying to remember what an ant looks like. Let me see. So the ant wants to get across the space as quickly as possible. So when you fold up the fabric of the space-time, it doesn't have to go all the way around. It can go from point A to point B, because it's going to go through the wormhole. And notice that my wormhole, if I complete it, is now a donut. Right, so here's a cross section of the side of the donut, like I had started making here, and like we saw over here. This is the same thing. Usually in books, though, they only draw this part. You know, in all those books that we've all been reading. Before I was looking more at the hyperspheres, I was just thinking about it in terms of cubes. Now, what happens if I take my one... This is my one cube, right? It's 1 to the 3rd because I've got 3 dimensions. But if I'm trying to add another dimension to that, the ultimate thing that happens is it's still forced into the restrictions of the cube shape. Right? It's mathematically crushed into occupying the identity of the number 1. So every time I multiply 1 by 1 again, the answer never gets any bigger. There's no room for expansion. So the force is that I'm trying to encompass more dimensions by spreading out, but I'm being forced to stay in the same unit of measurement. And what this looks like to me, before I was looking at the toroidal form and the spheres, is that I'm creating a pathway where my box is moving through space. And the way that I pictured this is as a wormhole. It's a means of propagation. So if I want to, in theory, right, because this is a download, I don't have billions of dollars for a lab. If I want to take my spaceship, I feel like this is the one that's like kind of the way the one that's on the wall in Egypt looks. If I want to take my spaceship and I want to, this is like a mothership here apparently because the Earth is going to be much smaller. If I want to take this ship, so let's make it a little bit smaller. Okay. Pretend that it's more to scale. And I want to go from Earth, let's do Africa this time. There. Something like that. Close enough to Madagascar. Alright, some islands or something. Alright. So if I'm taking my spaceship from Earth, and I want to go to, just put a big star here. If I want to go from Earth to Alpha Centauri, which is 4 light years away, I could either take 4 years, or I could apply this 1 to the infinite. I keep drawing that sideways. I want it to look better. If I take my 1 to the infinite power mathematical property, where I can push my 1 unit cube, let's just say that, you know, my spaceship is occupying my 1 unit cube, I can use this to make my wormhole to get to Alpha Centauri faster. I don't know how the mathematics is applied. Like maybe because I stopped the download or because I had too much other stuff going on in the real world, but this is the idea. This is the concept. And the other thing, the last thing that I thought about, oh no, before I got to that part, when I was still dealing with the squares, because this is going back to the squares and my propagation of the 1 to the infinite in the cubic basic concept, I was like, oh, okay, well, what if we're going to go to the Great Pyramid, which is crooked for some reason. Okay? You know, whatever. The Great Pyramid in Giza. So, and, you know, any other pyramid you'd want to think about. The idea I had was like, okay, well, what if we graph the square of everything, right? So we have 2 squared. So we have 2 squared, that's 4. If I have 3 squared, that's 9. And any other number that I square except for 1 going up to infinity keeps increasing, because 2 squared squared, right? 4 squared is 16, which is the same as 4 squared. So then I have the 16. Like this. And this is a way to increase space in the way that the 1 cubed, when it goes up to the 4th, wants to increase, but it can't because it has to maintain that same number. These can increase at will. So I've got 2 squared is 4, and then 3 squared is 9, 4 squared is 16. And we know that the Fibonacci sequence, phi, has the coding for the golden spiral. Actually goes out straighter than that, for the golden spiral. And I was like, well, what kind of spiral does this make? And I was trying to screw around with it. I'm like, you know, duh, because I went to school. We have a Cartesian graph. And if we graph the squares, this is negative, and this is positive. So you have the x and y axes, and squares form a parabola, which is a section of a cone. So this should be rounded. And the parabola looks like this. Because technically, it should take up both halves of the cone, the negative and the positive. And when I look at the double cone, what I'm seeing is that same toroidal wormhole shape, except that the midpoint is closed. So in some way, I'm seeing that these are related. But if I want to go from that closed clementine form to the open toroidal form, I need some kind of math that I can do that's going to open up the donut hole. This came later and wasn't part of the initial download. It was sort of like when I was unzipping the information. So we're going to go back to that idea of needing some kind of numeric equation to open the wormhole from the closed sphere. But when I was talking about the pyramid, what I was looking at these sequences of squares, and I say, okay, so there's like 2.3 million blocks in the pyramid, approximately 2.3 million blocks. And there's 210 courses. So if I say this is 1 and this is 210, I have 1 squared plus 2 squared, right? So the first course of the pyramid should be 1, and then the second course should be the 4 underneath it. And this is if we start separating it out. And then this one under here would have the 9. So in theory, because I made a spreadsheet, I would have about 3.1 million blocks, but there might be some missing, and there might be some relationship between these two numbers that I'm not really figuring out. I feel like the phi ratio should be in there, but I forgot to check it, and it's not that relevant. But I feel like in a logical sequence of pyramids, you would want to have things overlap. So you would put, if you were making a Lego pyramid, you would put down your 25 blocks. Your 25 blocks, and then your 16, and then your 9, and then your 4, and then your 1, and you would create this stepped configuration for your pyramid. And if you wanted it flat, you could get your casing stones in there. But this, and we already knew that the Great Pyramid is a stand-in for the hemisphere of the Earth. So I see again there's a relationship between the 1 squared as a cube, the one to the exponent being a cube, and the 1 to the exponent being a sphere, with where the insides are touching so that it's solid. Hopefully this isn't too confusing. For some reason, when I was researching this yesterday to sort of check my download work, I was like, okay, well, how do I open the top of the Earth so that it becomes the toroid with the wormhole in it? Right, the portal. And my brain told me pi over the square root of 2. And I was like, okay, well, where did that come from? But there was something I looked at, I don't know if it was on Wikipedia or what, that a 1 by 1 square, no, it was a 1 by 1 line segment. It might be a square, it might not. But if we say that the angle is pi over 4, then the hypotenuse is the square root of 2. So pi over 4, 3.14159 over 4, it's like point, it's like almost 0.8. So we have it should be a very narrow angle, or a very steep angle. So I'm not quite sure how that works. What is like an angle? So maybe it's a segment of a circle. I don't know. But anyway, the fact that I found this thing online that had a corner with 1 by 1 and an angle of pi over 4 next to the square root of 2 made me think that my pi over 2 relating to a number that needs to be applied to open the wormhole in a hypersphere made me think that I was on the right track. And we know that the pyramid is full of pi numbers. Now, I was thinking that if I take my toroid here, then I put it on its side. So I have now my donut is sideways. And I take my one, hopefully I can draw this correctly this time, to the infinite that I had with the square thing, and now I am propagating my little spaceship here. I have this wormhole that's being generated, so that I'm seeing the inside of the wormhole, and then there's this sort of spherical space that's around it. That's like the structure of this like donut tube, right? The walls of the wormhole. Because when you're in the wormhole, all you can see is the wormhole, and it looks like a ladder made out of clouds. And you don't know that there's some kind of ongoing structure. But when we see this from the outside, we're like, oh, that's a black hole. And we've just figured out that they look a little bit funky because of this hypersphere nature. The easiest way that you can show this concept is actually through kind of fun. So we're going to take a bin and you're going to fill it with bubble stuff. You know, the Dawn dish soap and some water, or, you know, the bottle of bubble stuff the big bottle of bubble stuff you can get at the store that looks kind of like a dumbbell, and, you know, the cap. Like that. And you take that big honkin' net thing they've got with the stick on it. Put a hand here. Right, they're pretty big. So here's a really crap depiction of somebody's arm. And you dunk it in there. And with these really big bubbles, you'll see people take them and they'll be like super iridescent, and they'll be running around in a circle with this big long bubble that's open on the inside, and it makes this big rounded tube, and it's all iridescent, and it has all these colors in it because it's all rainbow and shiny. There's a little shine spot. Okay, and anybody can do this. And it sort of illustrates the whole concept. We take a circle and then we end up turning it into this wormhole. And what happens when you're done blowing your bubble, this huge long bubble snake will collapse into a huge spherical bubble. Let me just put the green and orange in here again so you know that it's the same bubble. Where's the freaking, okay. Okay, so when this is released, when it's allowed to collapse in on itself and go from the toroidal form back into the collapsed spherical form, it goes from this wormhole shape into a sphere, or the planet. So E-bubble and toroidal wormhole. Okay, so that is, I don't think I forgot anything on my notes. Let me just double check that. The only thing that I missed was that when you're coming down from the top of these pyramids, you do like a spiral. Like that. And that creates a sense of rotation, which is a sense of time again, which gives you different perspectives in these sort of axes of time and space. Let me see what else. I'm just double checking. I did the parabola, we did the wormhole, we did the donut. I drew you this instead of a soccer ball. Oh! Yes, 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 yes. So anyway, I got that random pi over the square root of 2 number, so I did the old calculator and got the number. We're doing 6 significant digits here just for funsies, so it's 2.22, which is, you know, 111, very auspicious, the condensed 1111, twice. So we're like, ooh, fancy. And then the next one, 144, which is 12 squared, or a gross. Which is actually really close to this other number, 2.236047. We see that we're not off by a lot here, if we're rounding. The 2.236047 is, I'm just going to write it out, phi plus 1 over phi. So it's that like 1.618 plus 1 over 1.618. That's the golden ratio. And I'm not sure what the significance of that is. But that's as far as I got in terms of equations or whatever. Like I could do it if I really applied myself, but I just don't want to take the brain space at this point in my life. Like I did the math and the science until I went to college, and now I'm all into the geometry. So if somebody took these numbers and diddled around with them and said, okay, so we're going to say like 4, like if I want to make a wormhole this big instead of this big, this is like 1 plus pi over the square root of 2, and this one is like 4 plus pi over the square root of 2. Perhaps. That's sort of where I'm going with that, but I don't have any way to prove it. But in general, the whole concept starts with what happens if you keep squaring the number 1. You keep adding exponents to the number 1 and multiplying it by itself infinitely. And how does that look dimensionally? And what we get is hyperspheres. Where the hell is it? Where's my page? Representational hypercubes, toroidal forms, and wormholes. So, anyway, there's my spaceship in the wormhole. So I'm gonna leave it there. That's my whole deal. It took me a few days to settle into the information and work up the courage to talk about it as if I wasn't pulling shit out of my ass. So I feel like this is one of the better energy reports that I've had, and I mean, like, the information felt really profound, but it's like, hold on a minute, I can't do all this right this second. So maybe there'll be more, and hopefully you like that. Oh, I also found out that if you take a graph, like a sound wave, So say I'm listening to like smoke on the water, right? And my sound wave looks like this. If I were to take this and to make it into a three-dimensional form, it would be a spiral. Just like if I took my parabolic graph, you know, I could make a bar graph of those numbers. So I'm like, okay, so I'm 1, and then I'm 2, and then I'm 4, and I'm 6, 9, 16, and I could say this is now a spiral. And it would give me that opening of the wormhole with those numbers squaring. Okay. So perhaps my equation wouldn't just be like this is 1 and this is 4. I could say specifically that I want, somehow I want 1 to the infinity, like times pi over the square root of 2 plus 3 squared. And that would give me a certain diameter of the mouth of the wormhole, which might also determine the distance that you can go in it, right? Because wouldn't a 3-inch, like a 3-inch diameter wormhole would send you like 2 miles, and a 16-inch diameter wormhole would send you a light year, perhaps. But that might just be terrestrial thinking. I think that was the last thing. So any bar graph, you're only looking at it from one side. It's also three-dimensional, and it's going to end up looking like a spiral. Was that it? I think that's it. I'm just double checking my notes. Yeah, I don't think I need to show the whole spreadsheet with the squares, because relating to the potential 3.1 million bricks instead of 2.3 million here in the pyramid. Or if it's not individual bricks, it's units. 3.1 million units. And then they could have broken it down and had like a couple double wides or something like that. Okay. Is that it? Yes. All right. Don't forget to like, share, subscribe, comment, check out my playlists tab, check out the shorts tab for the dailies, and take it easy, and we'll see you later. Bye. Thank you for watching. Stay connected with Cat the Minion Energy Work. Check out my complete suite of goods and services conveniently from my Linktree. linktr.ee/cattheminion. Color your way into some relaxation with my coloring books Energy Forms and Draco Forms on Amazon. Get groovy with fashion and home accessories from my Cafe Press or Redbubble shops. Decorate your environment with original art and divination tools from my Etsy shop.